Hello everyone, this is Ahmed Mahmoud from DataMindAI. Today's session is part of AI Ready, Business Ready, Decision Ready series, and today is the last part of the AI Ready demo. We have this is part 5 of the demo, and it's going to be about feedback or closed loop learning, where we're going to see how to capture user correction for AI and the monitoring data and behavior drift, measuring decision outcomes, and then continuous improvement of AI systems. So, in a nutshell, what we are talking about is like how you need to make sure that your AI ready assessment is going to be done, and we are going to just touch what is required for AI development and what you need to focus on and to find out whether you are ready or not. So, as I was saying before, all we are doing here is like to have some kind of exercise within the AI environment for what is required, what is AI readiness is all about, and how to assess your organization on the AI readiness, and to give you first-hand information how things work and what to do for your assessment. And in a nutshell here, what I'm going to do is when you say AI closed loop learning, what it means is when we build AI solution, and especially this is it looks like a machine learning exercise. But it applies even for AI. Yeah. So what we do is we have, of course, we have the data. It's curated data, the silver data, which is validated and stable. It has a stable input. So now, when we want to use it for AI, what we need to do is we need to have features and labels. And this is very important area because, for example, we are saying there is a transaction and we have order table where there's a transaction. So we in that order table, the order of course is order ID is primary ID. But if you are going to learn the behavior of a customer, what we see is in that table, in that transaction, there will be many entries for one customer. Say, for example, in the retail industry, the same customer might buy bread, the same customer might buy, for example, milk, the same customer might buy clothes, and so on and so forth. So one customer will be seen in that transaction or in that order table many times. So therefore, that is not going to help us when you try to understand the customer behavior. So what we need is we need to aggregate the activities of that customer, which is very important. So we need to have a data set or an entry per customer to train it. So what we do is we aggregate or group the how many transaction or how many order that customer have done. And then what you can do is that order, for example, customer A might have ordered 5 times. Now, this is the order count. This is one feature we're building. Yeah. The second feature could be how much did he spend, total amount that he spent. And this is also a second feature. And so customer A, he ordered 5, order count is 5, and then the total amount was spent 1,000. And then customer B, he might order 2, and the total could be 500, and so on and so forth. So you'll have each customer will have the order count for per customer and also the total amount. Now, once we have done these two, for example, is a future. So we are building a future. And then we need to label. So what you are interested in. So we've done that one. For example, we want to know high value customer. So those who spend more money in that shop might be like high value customers. So you might say a customer who spend like more than £1,000 is like high value customer, and below that is a normal customer, standard customer. So that is a label, we say, if it's high, whether the customer is high value customer or not. So if he is, it's yes. If not, no. Or you can say 0 and 1, for example. So this is a label which will help us like predict if a customer comes in, whether it's going to be high level customer or not. Yeah. So that's again, that's the prediction we put, and then we train this to find the prediction. We train this model. Now we have a feature and label. So we do like a baseline training, and we trained again and again just to make sure that the outcome is reproducible. So of course, like the machine learning, we split the data into two groups. This feature, once we create this feature and label, we split it for training and testing, like any other machine learning. I'm not going to go through that bit, but this is the standard procedure. And then once we train it, like we create the model, the base model is called, or baseline model here. We might use like different kind of regression analysis or some kind of modeling side to it, and then we classify it. We can classify it as well, and we can do like fit classifier, as it were. Yeah. So we have like the test environment now. So we can also use a tester to evaluate the product. This is also a normal process. And once we've done that bit, we have like this quality metrics is called, like, for example, the accuracy based on the test we have done, the evaluation based on evaluation, the accuracy of the model, and we will have like precision recall in the F1. Again, that is, so we've done that bit. Now we deploy it and see, say, for example, we predicted, new customers, like they are going to be high value customers based on the level we put. And now we'll have like observation, human observation, whether what we predicted is happening. And based on that one, for example, those like, for example, human intervention, we don't just put them like email or in they talk about it. Oh, it is correct one or it is wrong. So whatever the observation is there, we need to put it in. We need to store it as a feedback in CSV file or in a table, so that to feed it into the system, So what we do is like we retrain the model with that feedback. And once the way we've done retrain it by giving, like, again, you split test and train, and then we go through that process of we take the test, so we test the prediction, and then what happens is like we see whether what is happening is whether any drift. We need to also monitor for a drift, so we need to have like a drift monitoring system. Now, what is this drift is all about? It is very important to understand here what a drift is. Like while we are doing our test, or while the model is deployed, the main data might change, behavior might change. For example, there might be change of a season, change of, for example, in terms of inflation might change, and based on that, probably the pricing, also the the range of values where we put the feature over there might change as well. So that's now the system have been trained in a certain set of data, yeah, but it is now there is a data drift, which means the distribution of the data from which our data had been trained might be changed. You might have another distribution of the data. So we call this one the data drift. Even also there might be a model drift, yeah, and also they might have like the meaning of something might change. For example, some word, some definition, which we might think is good at one stage, it might be bad, or we feel that it is very bad and offensive, but also be changing in later life. One good example is like the word bad. In a long time ago, it used to be like bad means bad, but this new generation or the use culture, subculture, change it to be like a very good one. So you have like this changing of behavior, which if you train the model to say this word is this word, it had this meaning, and then the context or the meaning has changed, it is going to change your model. So also this one is called a drift. So we need to monitor those drift, and this is what you need to understand. And this is the idea. This exercise is all about this drift. Drift will happen into your system, and therefore you need to have like a monitoring system where you can find, because the model will say something, and the reality might be a different thing. So it might your model or your AI system might be wrong. It will give a wrong or action because the main data, the thing which had been trained on has changed, but it's not reflecting those changes. Yeah. So this is the idea of this AI readiness and to understand this kind of behavior. So just to give you another example here, just again, say for example, when you create the feature and the label, this is like how to create those features and label. As you can see here, I was trying to say here, for example, you have curated data and then you need to create this feature and label. So what you do is like this is you would have, for example, this is the data you are having. You have a customer. This is customer ID, customer 001, 001. It is twice written here. And then what you do is like you aggregate those customer one, for example, is twice is mentioned. Customer 3 is been to mention it twice. And therefore, and then you need to have the amount. One feature is amount. The second feature is also the total amount, the count of the transaction. One is the count of transaction, which is 2, 1, and then you have the total amount. Yeah, so these are the two features we're talking about, and then we add a label to it. Say, and then we train using these two, the label and the new features. Yeah, we go train and we go through this process of the cycle we saw before. Yeah, so that's one area, and then the last one in here, what we do is like, what is a drift? What is a problem which is trying to solve? For example, as you were saying, your model is static, but you are dealing in dynamic data which is changing. Actually, the main point is like the distribution of the data. Yeah? The distribution of the data will change silently, and therefore we have one distribution where we learn where your model had been trained, and then you have another distribution shift. The distribution have shifted, but your model is still seen on the old distribution. That is again a problem where you need to monitor and change, do some technical solution on it. Yeah, that's what we're going to see mainly, and then you have an outcome for example, you are predicting something to happen, and as I said before, highly the prediction you are doing is based on the data you've done. So because the data has changed, and now the prediction also is going to change. So you need to train. You might have a new prediction, of course, yeah. And also sometimes people do it manually. They do the changes, but they don't reflect it into the system as well. So in a nutshell, what we need to do is like we need to have like a monitoring system and also human in the loop, it is called. So the people who are working also need to give feedback, and those feedback should be um, like fed into the system. So that's, I mean, that's again to be in the culture of AI, what needs to be done, and how to prepare your system into that site. Yeah. So now what I'm going to do is like I'm not going to spend that much time because it is most of the work here is like it is coming from the machine learning. So, and also what we are using here is, for example, as you can see here, this is we are bringing like train split to split our data into two. We have the classification reports, we have logistic regression, and this is a key part here. SciPy, for example, we from the SciPy we need to stats from the stats side. We are going to bring this case underscore two sump, which will help us monitor the drift. Yeah, it will give us comparing the model with the new with the real thing. Yeah, and its comparison, and then it will give us a statistical analysis based on that one. So that is a one. Which is very useful in this sense. And as you can see, you need to load the data, and then you need to do the aggregate, the one we're talking about. You need to have, and then based on that aggregate, we need to create a, a, um, a future. And let me probably go through some of it. I'm not going to go through every single bit. So what we do here, for example, the pandas and NumPy, we have looked at this one before. So scikit-learn, we from the scikit-learn, we are going to bring the train, test split, and classification import, and the logistic regression for the model. So this is I was talking about. This is you need to train and test and split them. Yeah, you split the data between train and the test, and then you work on the train data set, and then you do the classification using the logistic regression, and you create your model. What I'm going to do is for this one and the other one as well. In real terms, though, you need to bring a ML flow to help you on all this functionality. The ML flow is a very important tool which is going to help you. But here, just is as a crude system we are using, like the logistic regression to put your model there, and we are bringing this SciPy drift detection. Yeah, so that's so again, if you go through the system how this works as well, it will help how you can create your the the detection monitoring. You have this is a tool you need to use, and you import it, and this is how it's done. You can play with it if you want to. Just simple process here. As we were doing before, you need to have like a path which help us to navigate around the system here, or Python, which help Python to navigate around the folder structure and create a folder without any problem. And then once you've done this bit, you need to load your data. So what is going to happen is like you are going to create like a structure, like in your data, you have a created folder, and then within that one you have this silver older or silver set curated folder, and then the other side is the same. Like for example, I was talking about the customer ID, and then the order count and total amount, and then the label and value. This is like this is how you create them in a code. Yeah, and this is the your future and label. This is the futures we order count and total amount, and you can create them using this code on the top, and then you load the data, and this is the aggregate. You're aggregating. This is how you do it, of course, and yeah. So once you finish creating this future and label, and then training them, this is the training side. Now you are going to train, yeah, X and Y, and then once you finish the training, and you do the prediction here using the test data. So you train your model using logistic regression, yeah, and then you predict, and this is like the quality report, like the precision, the recall, the F1 score, and the sports. Yeah, so this is like in a nutshell the result you are getting, and this will help you, of course, to evaluate and to do like testing against the when you deploy it. Yeah, when you deploy it, the change which is happening. Yeah, so the model training and the evaluation baseline classifier. That's what we were talking before. So you can define the feature and target on your X and Y axis. Yeah, split them and then train the model, generate it. Now this is very important one. This is probably I will go a little bit the capture feedback. In real product, feedback comes from user correction. So if you have a user who's saying the outcome is bad, or their model is creating like wrong data, so outcome, which is did the decision help, or ticketing incident report, of course, also will give you a feedback. You need to capture those ones. Yeah, so you need to feed those ones. You cannot just put them in incident report. They need to come as a CSV or a table format and fed into the system, and then you need to be again tested, split tested, and then you model them. Yeah, and also even the human feedback also is very important. So you need to be fed into the system back, and train the system using these new ones, and you need to have like a new prediction. Yeah, so that's and then this is the retrain process, and the loading again. This is the same. This is machine learning. Probably I will spend a bit of time here. Data drift detection using case test. Again, you need to run the Kolmogorov Smirnov KS test. So this is the function. This is what you import. Yeah, and it will give you two values, and then total amount and total for the train and the test. You need to feed them both from the train and the test. So what this does is like compare the distribution of the future total amount. So you will have the distribution of the total amount between the X train, training time, baseline data, and X test, which is new unseen data proxy for production. Yeah. So the X test is non-parametric, and meaning it makes no assumption about the data shape. So the output will be ranges from 0 to 1. So the measures the maximum distance between two cumulative distribution. Yeah. So the probability that both samples come from the same distribution is a value. So log drift metrics as well. So you can print, and this one will convert value to plain floats for logging, dashboards, and monitoring system. So these metrics can be tracked over time, alerted, and stored for audit and governance. Yeah. So you can also interpret the p-value. Again, this is again a statistics and machine learning or data science. So if you have done some kind of data science, you will understand it quickly. If not, then you can go and just try to learn some of those ones. So I'm not going to go through all this stuff because it will take longer than necessary to understand. So the key part here is like we need the 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 drift and the like the looping. So you need to feed back to your system all the changes from outside the model, the changes happening, feedback from customers, feedback from people, feedback from the system you are running, and run them again and retrain the model again. So that's the side, and the closed loop is here. It is also, I think I need to mention this one as well. The closed loop here is like it means it's not for public. Your data does not go outside the system. It just stays within the system, within you. Everything is done within your environment. That's what a closed system is. Yeah, again. So again, the label is a key part here. So that is what is changing, because what we are doing here is, as you saw before, the label which we said before, like customer with high value. That is what we are predicting, and therefore that will be. It might change over time because the data have changed, and that is what we need to be careful about. And so that's what we are looking and then feeding back whenever the data is changing. Yeah. So I think that is what happens in a nutshell. So let me quickly go through that one with you. So the idea is in here. What you are going to do is simulate simple model that predict whether a customer is high risk. Yeah, and then capture user feedback or correction. So and measure performance before and after, and then detect data drift with a KS test. So that is what is going to happen here one by one, and you can capture the feedback here and then retrain with feedback. That is how you train it, and then you have the drift detection, and at the end, without feedback loops, Copilot hallucinate and never improve. Agents repeat the same mistakes, so trust declines over time, and therefore feedback turns AI from a demo into a living system. Say so. That is in a nutshell. Thank you for listening, and I will have another session. This was a demo about to understand what AI readiness is all about. The other tool is going to be like a real one, assessment, how to assess your system. So this was like an introductory to the assessment model, which I'm going to introduce. Thank you for listening here. All the script is there, and there was some errors within the script, which I just the errors had been dealt with, and I'm going to push them into GitHub so that you don't see those errors. And especially it was in two places the errors. Now the first one was like I was using different version of Great Expectation, and therefore I installed the latest one, and therefore the script didn't work. So what I'm going to do is like I'm going to update the GitHub, yeah, with the new or Great Expectation. And also there was a navigation within the folder structure, which was creating some kind of error, and therefore also that had been modified. The rest works fine. There's no errors with them. So if you find something, of course, please give me feedback. It will improve, and also it will make life for other people easier. Thank you very much. Bye.